on time. Welcome to another sunny morning of chemistry, Chem 12, wrong class, Chem 1105, with your host, me, Dr. White. At least I got that one right. And we're going to have a wonderful morning I have planned for you. We're going to have our first lab. All right, a couple important announcements. Uh, I got them written here so I don't forget. All right, today we'll be going through the lab after I do some of the lecture. And on Tuesday and Thursdays will be lab days. And I'll talk more about that later today. Now, important announcement. On lab days, I will go through problem sets. Therefore, since lab days are Tuesday and Thursday, next Tuesday, I will go through in our Zoom meeting, not all of it, but the important ones. And if you have any questions, I'll cover them too. The problem set for chapter 1 and the problem set for appendix A2 and A4. I like those fancy hand signs. But anyways, make sure you try them before I go through them. This way, you won't fall off. Remember, I talked about the bicycle. You can watch me do it like you watch the Blu-ray How to Ride a Bicycle, but until you try it yourself, you're not going to master it. By the way, wild blueberry tea from the Republican tea. And I highly recommend you do the problem sets before I do. And I try and give enough time, so you have between now and Tuesday. And in a normal semester, that'd be almost 2 weeks, but it's really just a couple of days. Please do them. Speaking about Republican tea, by the way, thank you for making me a YouTube star. And you can see I have the first two videos yesterday and the day before already on YouTube. All right, quick, I don't get any kickbacks. If you like tea and I do, this is the best place in the United States or anywhere, I think, probably, to get tea. Now, my favorites are, let's see, this is my all-time favorite. I buy it in bulk, 250 at a time. They like me. I've been buying from this. This is my first cup of, actually mug. My mug holds 2 cups of tea. My first mug of tea is vanilla almond. And the other one, which I'm drinking now, is the wild blueberry. And there are a couple other teas I like too, but these are my go-to teas. If you like tea, this is the place to buy it. I buy the round bags, not the loose. All right. All right. Let's continue where we left off yesterday. Yesterday, I was talking about numbers. And when you have number measurements, you have what's called significant figures. And I went through yesterday a number of rules, how to determine in a number how many significant figures it has. So let's start out the morning with a quick review. Oops, I promised I would print. And the question is, how many significant figures are in that number? And I'll let you try it first, then I'll do it. All right, looks like just about everybody's done. See, a lot of people are helping me out. Let's do it. All right. All non-zero numbers are significant. So the 5, the 1, and the 2 are. Zeros between two non-zero numbers, otherwise known as a confined zero, is significant. 0 at the end with no decimal point. I promise that I print, I still forget, is not significant. So that'd be 1, 2, 3, 4. This has 4 significant figures. And let's see what, okay. All right, why don't you try B, 38.700. And when you're done, give me a thumbs up or I'll put out a polling. All right, I think everybody's done. So let's take a look at this. How many significant figures are in B? 38.700. All non-zero numbers are always significant. So that's 3. Oh, look, we have a decimal point and zeros at the end with a decimal point present are always significant. So that'd be 1, 2, 3, 4, 5. So that would have 5 significant figures. Now, I still, once in a while, writing will slip in. Give the answer 4, and let's do the following. Remember, for multiplication and division, you get the same number of significant figures in your answer as the number you divide or multiply that has the smallest number of significant figures. I'll say it again. For multiplication and division, you get the same number of significant figures in your answer as the number that has the smallest significant figures that you're multiplying or dividing. And I think everybody's done. Notice this has how many? 2 significant figures. This has 3 significant figures, if I can abbreviate it correctly. And therefore, what's the smallest number? Hopefully I'll pick 2. Therefore, this is the correct answer because that has 2 significant figures. Now, we talked about rounding off. And why don't you round this number off to 4 significant figures? And for those who have your web camera on, thank you. And for those who don't, thank you for showing up to my class. If you'd like, turn on your webcam too, so Dr. White will be very, very happy. It makes me feel good to see students' faces, so I know you're alive and a real person. Or am I just talking to computers? I hope not. All right, I think everybody is done. You keep the first non-zero number, then the second, then the third, then the fourth, because I want to round off the four significant figures. The number to round off is 1. When that's 4 or less, that and everything afterward is dropped. When you're past the decimal in this case, that's going to be mainly the way you were going to round off. Therefore, the correct answer is 8.773. Let's do another one. Uh, all right, let's take a look at the following. I think everybody's done. How do you round this off? And this would be to 3 significant figures. Keep the 2, keep the 6, keep the 4. There's a decimal point there. This is the number to round off. Is it 4 or less or 5 or higher? It's 5 or higher. So I'm going to drop all this and increase this by 1. And the answer is this number. Now hang on 1 second because I have to respond to somebody. Give me a second. Okay, sorry about that. Not sorry. All right, now let's look at, now that you know how to round off, when we do math, let's take a look at the following. Let's make this. Now, if we have the following math, let me turn on my calculator. Now, I have mine in scientific notation, and the number my calculator just gave me is this. But let's do this. Let me do this. I'll do this one, then I'll let you try one. Remember multiplication, division. You have the same number of significant figures in your answer as the number that has the fewest significant figures that you're multiplying and dividing. Oh no, Dr. Whiteson is 3 sig figure, right? This is 3 significant figures. This is 3 significant figures. Therefore, our answer should be 3 significant figures, and this sure is not. So we have to round it off. Keep the 2, keep the 3, keep the 4, use the next number to round off. Notice I have a decimal point. This is 5 or greater. I'm going to drop this, increase this by 1. And the power of 10, I keep. And that's how you do it. So let me let you have some fun. And let me do this with my calculator first. And the number my calculator gives me and why don't you write the proper number answer, because that's not it. Use your knowledge of significant figures in mathematical operations. I think most people are done. All right. Now, Disha, I hope I'm pronouncing your name correctly. I have my calculator set up in scientific notation, and I'll answer your question in a second. Let's do this. First of all, this is 4 significant figures. This is 3 significant figures. How do I know that? All non-zero numbers are significant. Therefore, both this has 4 significant figures, 3. Our answer should have 3 significant figures. So I have to round this off to 3 significant figures. I have 1, 2, 3. My number 4 is this. Is that 4 or less? And the answer is yes. So I'm going to drop everything here because I'm past the decimal point. This I keep, 3.83 times 10 to the first. Now, one thing I haven't done in this class is show you how to go from scientific notation to decimal, because you're really not going to do it in this class, but I know how to do this. And this number, 3.83 times 10 to the first, is also 38.3. Now, on a test, for when this number is small like this, which is the right answer, let me rewrite this 38.3. Both are, because Dr. White knows how to do this, going from decimal back and forth. Now let's do one more, and that's this. Now, if I add this up, I would get this number. However, when you add, you get the same number of significant figures to the right of the decimal point as the number you add that has the fewest to the right. And all numbers past the decimal are significant. So this is 1, this is 3. Our answer should have 1. How do you round that off? This is my first one. This is to round off. It's 5 or higher. I'll drop that, increase this by 1. And the correct answer for this addition is this. Now, I'm going to let you try one. And why don't you try this one? In case you can't add and don't have a calculator, I'll help you out. And that's not the right answer. And the answer to your question, yes, it would be marked correct on a test. All right, let's take a look at this. How many significant figures? It's an addition. So how many significant figures to the right of the decimal point? All numbers, zeros or non-zero, are significant. So that would be 4 to the right of the decimal. Here I have 2. So now, which is a lower number, and hope you all pick 2, and therefore you have to round this off to 2 significant figures to the right of the decimal. Keep this, use this to round off. It's 4 or less, so I'm going to drop this. So the correct answer here would be 2.21. And that's how you do significant figures. Now, I just remembered something important. Ooh. I love that. It comes from a company in Germany that no longer exists. I've got 4 of them. They never leave my house because they're that valuable. But anyways, important announcement. On Tuesday, in the lab discussion period, I will teach you how to use your calculator using scientific notation, which will help you on all the tests. And so if you haven't gone out and bought one before Tuesday, buy one. Whatever you want, you can buy. As in my syllabus, I think this is the best one out there for the money, and that's the TI 30XIIS. And solar, so you don't have to worry about the battery running out as long as you're somewhere where there's light. And in this room, as you can tell, I have light. Actually, I worked hard to figure out the best lighting, so when I do YouTube, not YouTube, Zoom, it looks good. Do I look good? Oh no, it's getting totally obnoxious humor Thursday. All right. All right, thumbs up, people. Can you see the basic units on your screen now? Thank you. Again, Zoom sometimes will tell me I can and can't. All right. When we make measurements, there are 2 main systems for measuring things. One is called the English system. The other is the metric system. And in the United States, we use mainly the English system. But in science, we use the metric system. Now, I won't ever ask on a test, but in case you're wondering, metric, the word is derived from the Greek word metron, means to measure. I don't speak Greek, so I'm going to assume what I read in the books is telling me the truth. I hope it is. Any of you speak Greek, let me know and let me know that is true. All right. Now, ooh, what happened here? Now, the next couple of slides, I'm going to turn the switch, click. For some of them, this won't be on a test. But when we talk about metric, measurement of length is called the meter. And 1 meter is 100 centimeters, and 1 kilometer is 1,000 meters. And that's the measure for distance or length. If you ever get in your car, I don't know about the newer ones, I've got an older car, on the speedometer, if you have the dial type, you'll see on the outside the English system, and on the inside, like on mine, you'll see the metric, which has kilometers per hour as opposed to miles per hour, which is the English. And I guess that's if you go up into Canada, their speed limit, they use the metric. Just thinking, I haven't been to Canada in a long time, but being a big time hockey person, the Montreal Canadiens won last night. I'm rooting for them in the Stanley Cup because the Blackhawks, unfortunately, are long gone. They never even made it. Sad but true. But in the last decade, they've won the Stanley Cup a couple of times. All right. Whoa, I don't know what happened to my slides here. But anyways, for volume in the metric system, it's liter. And 1 liter is defined as 1,000 cubic centimeters, and 1 cubic centimeter is equal to a milliliter, which I have down here, and therefore 1 liter is 1,000 milliliters. Now, if you go to the supermarket, you can buy bottles of pop. By the way, I should mention, I've spent most of my life, not only my adult life, in the Chicagoland area. For 5 years, I was in Michigan, East Lansing, getting my PhD, and at times for a couple weeks at a time, 2 to 4 weeks, I've been in Europe, Canada, or South America, mainly Mexico, on work. But most of my life, like almost all of it, I've been here in Chicagoland. And in Chicagoland, we call the carbonated non-alcoholic beverage that you can buy in a can or a big bottle, plastic bottle, pop, not soda. But anyways, if you go to the supermarket and look at the big pop bottles, they're 2 liters. And that's circa about, I want to say the late 70s, early 80s, 1980s, that is. There was a big drive in the United States, and it might have been a couple of years earlier or later, to convert to the metric system. We use the English system. If you go to a gas station, volume is gallons, not liters. If you're in Europe, they sell gasoline by the liter. And I've worked in Europe, so I know that, especially the Netherlands, great country. But anyways, there was this big push to go to the metric, and it failed. Most people said, no, I don't want that. Well, when that push was on, you'll go into a supermarket and you can see the 2 liter bottles of pop. And that was part of when they had the push. Pop companies said, all right, let's try and we'll put it out. Now, besides my tea, I have a water bottle, and on the bottle, it has both metric and English. It says 23.7 fluid ounces English, and it also has 700 milliliters in brackets. And another example of metric and English system, if you go by certain signs that have the temperature, like by banks and other places, they'll have Fahrenheit, but they also have Celsius too. But in the United States, it never really caught on. All right, now, in the metric system, mass, which is another way of saying measuring weight, is the gram. And again, switches off, but we'll be using these throughout the semester. And the mass is a measure of quantity, weight is a measure of total force by gravity. But since everybody agreed that you're not going to leave the planet Earth this summer, like going to Mars or the moon or other planets, we'll use interchangeably mass and weight. And the weight for the metric is a gram, and 1 kilogram is 1,000 grams. Now, kilogram is the name, but it's been abbreviated like a kilo. If you ever watched those movies, or better yet, Miami Vice, which I wish they brought back on. That was a great TV show in the 80s, violent but great. And it was about in Miami, and a lot of it dealt with drug trade. And you'd hear on that, or you can see in movies where one of the villains say, "What time is the cocaine coming in? 500 keys are coming in at midnight." And what they mean is not your door keys. They're talking about kilograms. And that's, I guess, the unit drug smugglers work in, not pounds. Don't ask me why, because that's an area I've never worked in, don't plan on it. All right. Switches now click on for this slide. Now, when you have the metric system, we have certain prefixes that are important. And one of them is kilo. Kilo means 1,000. So a kilogram, K-I-L-O in front of gram, means 1,000. And there are a couple of them I'd like you to know on this chart. Kilogram is one of them. If you have a computer, how many megabytes do you have in, say, whatever, your memory? And that means 1,000,000. And if you have a hard drive, smaller ones now, gigabytes, that's 1,000,000,000. Now, centi, like in centimeter, is 100th. And you should know this prefix means this number, both scientific and decimal. And then milli, like in milliliter, is 1,000. Again, centi is 100. Milliliter is 1,000. Kilo is 1,000, which is what 10 to the third is. And those are the three I'd like you to know for my class. But micro is 1,000,000th and nano is 1,000,000,000. I won't really teach in this class, but since 1995, there's been a lot of research, chemical research, and a lot of government money from many governments in nanotechnology. That means things that are a billionth of a meter. Things, molecules and other tubes that are very, very small. But you should know, hint, what is a kilo? The prefix, 10 to the third, 1,000. What is a centi? It's 100th, 10 to the minus 2. And what is a milli? 10 to the minus 3. And those prefixes, like a milliliter, milli is the prefix, that's 1,000th of a liter volume. Centi, centimeter is 100th of a meter length. And kilogram, 1,000 grams. And you should know that. See, I even got it on the slide. Now, switches off again. The way the book was written is they have something called conversion factors, and they call it dimensional analysis. I like the old name, unit analysis. And this is a conversion factor. Again, right now, switches off. Now, be a week or two before we start doing any calculations. Everybody take a deep breath. We're going to be doing some calculations in this class, including, relax now, some algebra, relax. Whatever calculations we do in this class, I will teach you the math, how to do that. Because when I teach, there are no blanks the students have to fill in on their own. Therefore, I'll be teaching that. And one of your best, or I should say mine, and it will be yours soon, your good buddy, your good friend will be unit analysis. Now, I won't teach it now because why teach it now when you won't use it for a week or two and you'll forget, and I'll have to do it again. But unit analysis is a conversion factor and shows a ratio, how to go from one unit to another. And something like how do you go from inches to feet? How do you go from, if I tell you to go to the supermarket and get me a dozen eggs, how many should you buy? 12. And I'll teach you, and how do you go from gram to kilogram? And you use significant figures in all these calculations. But I'll teach you unit analysis, how to do that later. Your lecture will cover this at a later date. All right. Switch is still off, but I'd like to teach you. It's in the book, and we're going to have a lab next week on this, so you'll get some more practice. Density. And what is density? Density is the ratio of the mass or weight of an object to the volume of an object occupied by that object. And therefore, density is mass of substance divided by volume. And many things have density that you can look up, and we'll be doing a lab. And this will not be on any of my tests, but water has a density of 1.00 grams per milliliter. Now, one of the important things about density is low density items float on top, forgot this, of higher density. I won't ask that on a test, but when we're talking about density, this is something you've probably seen. And if you take a piece of cork and put it in a bucket of water, that cork will float. And many, many years ago, life preservers, they're not made that way now, but were made of cork with a fabric around it. Why? Because cork floats on water. Water has a density higher than cork. Now, just the opposite, if you have a high density item and you put it in a lower density liquid, guess what? It sinks. So if you happen to have a big barrel of water and a cannonball made out of lead, if you drop the cannonball into the bucket of the barrel of water, guess what? It goes whoop all the way to the bottom. Why? Lead has a density, I believe, about 15 or 19 grams per milliliter, where water is only 1.00. So it sinks. So it's an important thing, and items can be both solids or liquids. How many of you, and somebody asked a question, I'm getting behind in my checking. Someone came up with a good observation. Oil and gasoline and vegetable oil have a lower density than water. And if you ever go to a gas station after a rainstorm, you can see a thin layer of gasoline, or if somebody was changing their motor oil floating on top of a puddle of water. Now, Oh, I have to warn you something. My mother was a very good amateur artist, and I inherited nothing of that. So whenever I do artwork, I have to warn you, don't laugh so hard that you hurt yourself. Please don't, but you're allowed to laugh your head off. But I will never, ever, never, ever had any thoughts of going to art school. It is not one of my things. Now, let's assume you have a container, a glass. Let me straighten it out. And in there, you put oil vinaigrette dressing. And after a while, you'll see a line, and the bottom will be the water or the vinegar, which is mainly water, and the vegetable oil will be on top. Why? Vegetable oil has a density of about 0.7 to 0.8, and water has a density of 1.0. So it will float the vegetable oil, or gasoline or motor oil too will float on top. And that's density. Again, density is weight per volume, and lower density items float on top of higher density liquids, and higher density items sink in lower density liquids. And if you're a fisherman, which I'm not, trust me, I've never gone fishing, but I've seen people talk about it, and friends have. You know how you have the little weights you put on your, called sinkers, that you put on your fishing line to get the hook down? And those are made of lead. Why? Because they're denser, higher density than water, and it causes the hook to sink down so you can catch the fish. How you like that fish? Nah. Anyways, that's that. Oh no, we've come to the end of this chapter. And you know what that means? It's time for a new chapter, new stuff. So let's go on to chapter 2. Well, let me remind you, don't forget, on Tuesday, I'll be showing you in lab how to work a scientific calculator. Also on Tuesday, I will be going through the problem set for chapter 1 and appendix to problem set for appendix A2, A4. I highly recommend you do those, work on those before I do. And if you have any questions, don't forget, ask them. Because in my class, in my world, there's no such thing as a dumb question. All right, chapter 2 deals with atoms and atomic structure somewhat. And first, it's time for a commercial from Dr. White, or public service announcement. Don't forget chemical symbols. I'll never ask what they are, but let me remind you, those are 1 or 2 letter abbreviations for the name of the elements. You don't have to copy this down ever. Only the first letter, if there are 2, if there's only 1, it's also the only letter, is capitalized. If there's a second letter, it's always lowercase. Now, in the periodic table, I think as the most current one, there are 118 elements. And most of those you are never going to encounter in your daily life the rest of your life. And I'll bet on that. By the way, if Dr. White says he'll bet on it, I already know I've won, so never bet with me. But anyways, I work in the real world. I live in the real world. And I expect you to only learn things that are in the real world. So here's my list of elements you should know, both the chemical symbol and the name. You should know oxygen is O, sulfur is S. Ooh, here we have silver, Ag, copper, Cu, My favorite, carbon, because I'm an organic chemist. Remember the four branches of chemistry: organic, analytical, inorganic, and physical, but the best is organic, but I'm an organic chemist. And you should know things like Na is sodium, Ca is calcium. Remember, calcium helps make strong bones. I take my calcium supplements, so I don't have osteoporosis at my age, thank God. Not to bring religion into the class. So you should know on a test, if I ask, what's the chemical symbol for potassium? You should know it's K. What's the chemical symbol for uranium? U. If I ask the chemical symbol for He is what? And that's helium. So you should be able to, given the name, write the symbol, given the symbol, write the name. And if you haven't started learning these, you're not going to learn chemistry well the day or two before a test. Now, in the chapter, they talk about mole and molar mass. We'll get to that later for those of you. All right. If I look at the time, let me go through this quickly and we'll pick up after a break. Chemical formulas. I'll never ask you what a chemical formula is, but that's the notation made up of the symbols of the elements present in a compound and the numerical subscripts, that's numbers located to the right of the symbol below, that indicate the number of atoms of each element present in a molecule of a compound. So chemical formulas are important. And seaboard, for example, oh, I got to get to work. Before we take our break, let's do a chemical symbol. Does everybody see my whiteboard? Thumbs up, people. Thank you. All right. Let's start out with a simple one. H2O, hopefully you all know, and by the end of the semester you should know, this is water. And how many atoms in there? Notice I have a hydrogen, hopefully you learn your chemical symbols, and it's got the subscript 2. So there are 2 here, and I have an oxygen, so 2 plus 1 equals 3 atoms in water. And with that, it's time for our break. I'll see you back in 5 minutes, and we'll continue on. Time to get going. Everybody back? Let's get going. All right. I was talking about the chemical formulas or formulas for molecules. And I'll teach you what a molecule is later on. And the first one we did was water. So I'm going to let you try one. How many atoms are in this? This is called sodium chloride. And I'll never ask you on, well, maybe I will. And you know that as table salt or just salt. And sodium chloride is what you put in your food to make it taste better. When you add salt, you're adding this molecule. And I'll let you try first how many atoms are in sodium chloride. And you also put this on your French fries, at least I do. I haven't had French fries in ages. I need them like a hole in the head, which I don't need. All right, I see everybody's putting down the correct answer. Let's do it. One sodium, one chlorine atom, so there are two atoms. By the way, if you ever go out to lunch or dinner with a bunch of chemists, and I have unfortunately been or fortunately been guilty of this, we'll ask, could you please pass the NaCl, NaCl, NaCl? All right, let me show you something important. Now, for certain molecules or formulas, when you have what's called a polyatomic ion, which I'll teach you later on, you have the following. This is called calcium hydroxide, also known as lime. Not lime like you eat fruit, but the chemical. And how many atoms are in lime, calcium hydroxide? And you have one calcium. Now, notice I have this bracket here, and I have symbols inside. And to the right subscript of the bracket, I have the number 2. And what you do is you multiply anything in here times the number here. So that means I have one calcium, 2 oxygen, plus 2 hydrogen, and there are 5 atoms in Ca bracket OH2, close bracket, and calcium hydroxide. And why don't you try the following? Nope, that's not the one I want. And why don't you, in this molecule, I think you're up to it, how many atoms total are in that molecule? I see a few of you have it, but, oh, I haven't done this in a while. All right, looks like just about everybody's done, so let me do it. Now, first of all, we have one magnesium, but notice here we have this bracket, and subscript, we have the number 2. So you multiply this times how many atoms you have inside here. So 2 times 1 hydrogen is 2. 2 times 1 carbon is 2. But now we have 3 oxygen here times 2, and that's 6. If I do my math correctly, if I don't, somebody correct me, that has 11. Now, let's do a couple more. By the way, that's magnesium bicarbonate. Why don't you right here, let's call it C, D, E. Why don't you work on E? How many atoms are in the molecule E, calcium chloride? And I see the numbers are coming in, so I think everybody's done. We have 1 calcium, and notice the subscript here is 2. That means we have 2 chlorine, and that means there are 3 atoms in here. Now, this is called calcium chloride. I'll never ask that on a test. How many of you have ever used in the winter? You know how when it gets real cold, I mean real cold in January and February, and you have ice on your sidewalk or driveway, and it's so cold, regular rock salt won't melt it. What do you put on there? Those little white beads or pellets, and that's pure calcium chloride. And calcium chloride, CaCl2, will melt ice, convert it into water, so it rolls away or evaporates very quickly at low temperatures. And I'll teach you later on in the semester why that's true. And why don't you try this one, calcium nitrate? How many atoms are in calcium nitrate? See, Dr. White likes to share the fun too. And I see some people are already answering, so I better get to work. Now, how many atoms are in this calcium nitrate right here? Well, first of all, there's 1 calcium. Now, oh, we have a bracket. And notice here we have the number 2. So we multiply 2 times everything inside. So we have 1 nitrogen times 2, that makes 2. Then we have 3 oxygen, but we have to multiply it by the 2, and 2 times 3 hopefully is 6. If I add this right, it's 9. Let me write it again bigger. So there are 9 atoms in calcium nitrate. And that's how you use the chemical formula. And I thought you should know how to do that. And now you do. Now, an important part of chemistry is the periodic table. And the periodic table switches off on this slide in terms of, I'll never ask you what is the periodic law, but Mendeleev was the one who came up with the best way of doing it. There are others who are working on it too, and that is when elements are arranged in order of increasing atomic number, elements with similar properties occur at periodic, which means regular occurring intervals. And using the periodic law, Mendeleev created what's called the periodic table. I will never ask you on a test or a final, what is the periodic table? But it's a tabular, meaning a table arrangement of elements in order of increasing atomic number, in which the elements with similar properties are positioned in the same column of the display, otherwise known as the periodic table. Now, let's look at a periodic table. That's not the periodic table. All right, where did I hide you? Right here. Can everybody see the periodic table on your screen right now? Thank you. Now, this is my favorite on the internet. It's called Dynamic, and whoever created this one of these years, I'll find out, and I'll send an email thanking him. And this has, notice here, your different elements. Here's hydrogen 1, then helium 2, lithium 3. Notice how when you put your cursor, it shows up over here. And each column is important. Now, the columns, except for the first one, hydrogen isn't considered part of the family. A column is called families. And in the first one, notice it's different color. The first column is called the alkali metal. If I go like this, look at something cool. See how it lights up? And the alkali metals, the ones you should know, are alkali metals are lithium, sodium, potassium, Li, Na, and K. There are others, but we'll not work with those in this class. But lithium, sodium, potassium are in our daily life. So if I ask on a test, give an example of an alkali metal, you would put down lithium, sodium, or potassium, any one of those. Now, a second column right here is called the alkaline earth metals, alkaline earth metals. And the only ones I've asked you to learn are magnesium and calcium, Mg and Ca, because those are in our daily life. Magnesium is in the center of the molecule chlorophyll, which makes plants green and allow them to make oxygen from carbon dioxide and water, and also make other things that we use from photosynthesis. So magnesium is important, and calcium, like I said, helps keep your bones strong, among other uses. And those are the alkaline earth metals. So on a test, if I ask you, give an example of an alkaline earth metal, you could write down either magnesium or calcium. Strontium is, you won't use, but it's nice too, but those two. Now, all the way over in the second to last column, and they don't have a thing for it, this column right here, fluorine, chlorine, bromine, iodine, it says up here, are the halogens. Now, these other names I've never used, but you should know fluorine, chlorine, bromine, iodine. I've never used astatine. I don't think you will either, so that's why I haven't asked you to learn that. But fluorine, chlorine, bromine, and iodine are important. Chlorine is part of sodium chloride, table salt, and fluorine one uses to make non-stick pots and pans. But anyways, these are the halogens, and you should know what are the halogens. And if I ask on a test, 2 points. Give an example in the chemical symbol of a halogen. You could put F fluorine, Cl chlorine, Br bromine, or I iodine. And finally, the last one, which they do have column on the right, are the noble gases. Now, up until about 1995, these used to be called the inert gases because chemists said they don't react. Then some very ingenious chemists found a way to make them react, and you couldn't call them inert anymore, and they changed the name to noble gases. And I will have to admit, I still, once in a while, it slips out of my mouth. I'll call them inert gases. It's really noble gases. Oh, by the way, that person won the Nobel Prize in Chemistry for doing something that nobody thought you could do. Now, if I ask on a test, give an example of a noble gas, the name and chemical symbol. Well, you can put down neon, helium. Remember, helium's the stuff in the balloons, and argon I've worked with. And krypton, remember, Kr, is a colorless gas that doesn't kill Superman. And xenon, you should also know. And so if I ask, give an example of a noble gas, argon would be my choice, mainly because I worked with a lot of that when I was in grad school. And those are the families, columns of the periodic table you should know. The alkali metals, lithium, sodium, potassium. The alkali metals, lithium, sodium, potassium. The alkaline earth metals, you should know, magnesium, calcium. The halogens, that's not what I want done. The halogens, fluorine, chlorine, bromine, iodine, second to the right column. And finally, the noble gases. And by the way, if you click on things like I do, you can find out this does a lot of amazing things, dynamic periodic table. And we'll talk more about it throughout the semester. But this is the periodic table, and the one you use, I've already shown you, doesn't have the names. And the first column, other than hydrogen, which is not part of it, are the alkali metals. Second column, alkaline earth metals, magnesium and calcium. Over here, second to last right column, fluorine, chlorine, bromine, iodine. And finally, the noble gases, the column all the way on the right in the periodic table. And that you should know. And here I have key groups on the periodic table have special names. I just went through alkali metals, the first column, second column, and the first column does not include hydrogen, even though it's there. Alkaline earth metals, the second to the last on the right are the halogens, and finally, all the way to the right are the noble gases. And I even have it on the slide. Hint, you should know which atoms are in each of the aforementioned groups: alkali metals, alkaline earth metals, and the halogens. Any questions? Now, in our daily life, there are certain words we use, and where do they come from? And one of them is a metal. And a metal, what is that? A metal is an element that has the characteristic properties of luster, thermal conductivity, electrical conductivity, and malleability. And I will never ask you what are the properties, but I thought I'd mention it. But you should know at least the one or two examples of a metal. Now let's look at that. What's luster? Luster is you can shine it up. If you rub on a metal, notice I have my ring on, my class ring from college. Oh, I should show you. Can you see the date on there? It says 1972. Wait, I shouldn't have said that. This is when I got my undergrad from Illinois Institute of Technology. I wear it on this finger to honor my father because he always wore his college ring on this finger. And one of the most important things in my life was to get this to honor my father, which to this day I still do. Great man. But this is gold, and you can shine it up. You can do the same thing for silver. Now, if you take a piece of calcium, you can't shine it up because it's not a metal. If you take copper, yes, you can shine it up, and that's luster. Now, thermal conductivity, it conducts heat. That's why pots and pans mainly, like years ago, somebody tried to sell pots and pans commercially made out of glass. That didn't last long. But pots and pans, metals conduct heat. they also conduct electricity. And in your cell phone and other places, you have copper. Sometimes you'll have gold wire or contacts, and they conduct it. Now, back in the 30s and 40s, they were starting in new houses to use aluminum, Al. Unfortunately, they heat up when you conduct electricity more than copper, and they had house fires. So about 1950s, most communities in the United States outlawed the use of aluminum for electrical wires. Now, what's that last word? Malleability. Ooh, that's a big word. Malleability means you can pound on it and thin it out. How many of you have ever seen gold leaf? And it's super thin, almost like onion skin. And you can take gold and push on it and push on it, pound it, and make it thinner and thinner that way. Now, how many of you have ever seen aluminum foil? If you look at aluminum foil you buy, one side is shiny, the other is dull. Why is that? Well, when they make it, when they go to polish it, because it's or first of all, it's malleable. They thin it out, make it thinner and thinner by pushing it through rollers. Well, when they go to polish it, because it has luster, the aluminum foil is too thin for the polishing brushes on one sheet. So they put two sheets together, and it can only can't polish the insides, and it goes through the polisher like that. And that's why aluminum foil is only shiny on one side and dull on the other. And someone is saying brass is fun to shine, which made me remember when I was very young and we'd have company come over. My parents would take out their fancy silverware and the silver serving tray and other things. My job was to polish the silverware. And my mother was a fanatic. Not only would the silverware had these little beads and everything in it, it was very fancy stuff. And not only with the polish and rags would I have to shine it, she'd give me an old toothbrush that inside the cracks I'd have to shine. I hated doing that. Oh, did I hate it? But it looked nice afterward. Now, in terms of shiny or not, that has no effect on how it affects the heat in your oven. Now, if you're using it as a reflector for light, it might, but that's another story and something else. That's a good question. So what are examples of metal? Aluminum, copper, gold, lead, tin, zinc are all metals. Now, we also have a non-metal, switches off, and non-metal lacks the properties that metals have: luster, thermal conductivity, electroconductivity, and malleability. And don't try this at home, but if you take a diamond, which is carbon, if you hit on it, it's not going to get thinner, it will break. That's why they have diamond cutters. If you've ever seen, go to YouTube, I'm sure they have something on diamond cutters. Now, the last one is metalloids, and I've never really used this. And these are elements that have some of the properties of metals and some of non-metals. They're very important. Silicone is one of them, and others, and those are used in things like our integrated chips or circuits in our cell phones and other electronics, such as my webcam, and if you have yours on, your webcam. Oh no, we finished chapter 2. So, you know what time it is? It's lab time. And in a face-to-face, to make up for the time I'm going to lose on July 5th, and I looked at my syllabus and, oh no, I forgot to put it in there. Sometime today or tomorrow, I'll change it. By the way, the person, thank you, who saw the mistake, I had 2 the same date in July. I fixed that already, but I'll fix this too today or tomorrow, that I didn't say Monday, July 5th is a holiday, school and country, and we won't have class that day. But if we were in face-to-face, let's start the lab. Give me a second while I open up stuff. If we were face-to-face, you'd be waiting too. All right, thumbs up, people. Everybody see on their screen the lab syllabus? Thank you. All right, first of all, any student found violating the code of ethics in conjunction with lab will receive appropriate punishment determined by me. In other words, don't cheat, don't fake things, and don't copy from other students' answers. Labs should be done essentially on your own. You can talk about labs with other people, but you shouldn't copy their answers. You should do that. Now, this semester, we're going to be doing laboratory experiments, and we'll be using, and I'll show you in a second, most of it will be done on a lab simulation product called Beyond Labz, which is quite good. Now, we're going to do 14 labs. Your 24% of your grade will be based on these lab reports that you'll hand in. Now, if we're face-to-face, I do attendance, but I'm not going to do that. And each laboratory is worth 10 points. And I started long ago, what happens if you have a bad day, or if we were face-to-face, what if you were sick? So to handle that, since you can't make up a lab when we're face-to-face, simulations you can, I'm going to only count the top 13 out of 14. So 10 times 13, the labs are worth 130 points out of 513. Now, lab reports, and this is important, are due in the next lab session after the session for which the lab report is being handed in. You'll get 0 points, 0, for a laboratory experiment that is not, if the laboratory report is not handed in. You'll get 0 points if a lab is more than 2 days late. Now, throughout the semester, you'll be downloading Labz. Good thing, since we're doing this online and with Labz and also what I wrote, you don't have to buy a lab book. So that saves you $50 to $100 right there. Now, let's talk about labs. We're going to be using a product Beyond Labz. How do you get that? Well, you need an access code. And in my syllabus, I show you the link to the bookstore. Remember, I talked about a number of years ago that the legal counsel of COD, College of DuPage, sent out emails to all the faculty, including I got one, that because of the contract between Follett, which is the company that runs the COD bookstore, and COD, faculty are not allowed to tell students where to buy any books or other things that you need for a class. They have to go to Follett's. And if you do, you can get sued. And Dr. White doesn't need to be sued. They also said the school could be sued. So I cannot tell you that, but I gave you the link where one place to get it. And let's go to the internet. The product we'll be using is Beyond Labz. And thumbs up, people. Everybody see Google on your screen now? With the thank you. If you click on Beyond Labz, it will take you to the screen right here. And if you look in the upper left right-hand corner, you have log in. And I'm going to log in. And you can save this as a, once you register here, I've already registered, you'll get an use your activation code, which will be sent to you. And everybody see on their installation and setup on your screen? Okay, thank you. Now, I don't have to do it because I've already downloaded it. And you'll download some stuff for your computer. Right now, Beyond Labz is working on this summer, having this so it'll all be, which won't help us, but in the future, HTML, so you don't have to download. But for this, one problem I had with a student last semester, and that student had a very, very old Mac computer, which this wouldn't run on. And she was able to get another computer. If you have that problem, one place you can get, I don't know if they still have it, but you can check and I can find out, give you the links for it. COD does give out computers for students to use during a semester. I see a question. No, Jada, what you have to do is purchase the code from the bookstore, and then they'll send it to you. They were sending it by the US mail, which was pretty awful. That's why earlier I sent out an email, buy it now, because when you get it from the bookstore, they use US mail. I had some students took up to almost 2 weeks to get the code. You don't have to buy the book, but you buy it from the bookstore. They're separate things, so hopefully that helps you. If you have any problems with this, let me know, or you can go to Beyond Labz community, and you don't have to sign up for that. And if you have problems, you put it in there where you need help, and they'll help you. All right, now once you've downloaded it, you'll come back to this initial setup. And the first time when I came back, I said, oh, what happened? I didn't realize in the lower right, it says connect. Now I'm going to click on connect. And does everybody see on the screen Beyond Labz? And welcome. Thank you. Now, we're going to be using the chemistry lab and the physical science. You download all of these. If you notice, there's 2 versions, higher ed and high school, and some will use both of these. Let me show you one of the labs. Let's go to physical science. I'm going to open it. Click on open. Does everybody see welcome to virtual physical science on your screen? Thank you. Now the lab we're going to do is density. Check this out. Is this cool or not? Hear the noise it makes? Let me check. All right. Does everybody see the word exit on your screen in the lab? All right. Now, you're going to be doing a density lab, and there are different solids here and different liquids here. And next week, I'll show you, I think we do this Tuesday. If I want to pick a different, no, it's not the one. Notice I have water here, and I'm going to fill the graduated cylinder. And then you can measure the volume by clicking on here. And you can see this. I'll teach you this next week. But I want to show you something neat. Different density things like titanium. If I put it here, and will this sink or float? I don't know. I'm going to drop it. Oh, it sunk. And then you can do another experiment. I can fill it again with water. All right. Ah, wrong thing. Nope. Now, watch closely. This is sodium, and I'll teach you this reaction later on. It's there. I'm going to drop it. What happened? I'm going to drop it. Watch closely. You never want to put sodium in water. Is that neat or is that neat? And you can exit it. And that's beyond Labz. They've done a good job. In fact, you can keep a secret. I've been working with them to help make some of their labs better. But anyways, we'll be using that. And a couple of labs that will just be my own labs writing. So that's beyond Labz. Now, where do you find labs and do stuff? Not me. See a question. If you can't connect, are you saying you don't have internet service or you just can't connect?
I just can't connect. It says connection error. So.
All right, well, let's talk about it after lab. I'll show you where you can get help from beyond Labz. And if you can't, let me know. I know some people who work there that I've worked with, and I can contact them to get you help.
Okay, thank you.
And like I said, if you have problems, go to Beyond Labz. I'll get to that at the end of a little while. All right, now. All right, let me make sure. All right, everybody should see Blackboard where it says announcements. And on the left, see where it says assignments? If you click on that, you have assignments. And notice I have the signature sheet where the first two you can download. One of these, you should fill this out and upload it once you've created a PDF file after you filled it out and signed it and dated it to here. Now, for lab one, notice I have both as a Word document and a PDF. You should download one of these because you'll need that for today's lab when you hand it in. Now, all labs are due to next lab period. And if you're more than 2 days late, you get 0 points. You just lost 10 points. Labs are easy points. I'm not one of those who looks at labs as a way I can take points away from a student. No, they're for you to learn and have a good time. But if you don't hand it in, you're going to lose a lot of points. So don't. Now, under here, I have files. If you don't have a scanner, how to use your cell phone as to take pictures to make PDF file of your lab and also your test. And I have instructions here too if you don't want to use CamScammer. If you do use CamScammer, don't pay for it. Use the free version. It's good enough. You don't have to have all the extra fancy bells and whistles. Now, once you've downloaded this, let's talk about today's lab. Now, if we're in the lab, first of all, I don't have up here handy. Hold on 1 second. Maybe I do. Give me 1 second. I'll be right back. Don't run away. I'm back. I can go through this again. In at COD, when we're in a lab, you need safety goggles. Safety goggles protect your eyes. Laboratory can be a very dangerous place if something goes wrong. And the most important thing in a lab, first of all, is to protect your eyes. When I was in grad school, a friend of mine, another group, was doing a dangerous reaction. He'd done it 45, 50 times before, but that day he rushed it. It blew up in his face. Luckily, he had his goggles on because I remember waiting in the emergency room with his wife when the surgeon came out and said, "Your husband's very lucky." He had in his face close to 400 stitches, 2 and 3 placed at a time. He said, if your husband hadn't had his glasses on, he'd be blind right now. And that taught me real quick, even though I had been, you should always wear eye protection. The most important is, you should be taking notes now, the most important piece of equipment in the lab, first of all, is your safety goggles. Now, in the lab, we wear proper things, and let me open up the lab for you. Does everybody see Lab 1, safety? Now, there are a number of videos in here on YouTube. I'll let you watch them on your own. I don't have to do it now. And I'm going to go a little longer, and we'll get out early today. Yay, I think you'll like that. But anyways, here's one talking about proper protective equipment. You've heard the term PPE, unfortunately, in terms of COVID-19, but in the lab, and in each lab we have this. You should always wear your goggles. Students have to buy their own. If you have long hair, it should be tied back so it doesn't go into chemicals, or if you're using a Bunsen burner or a flame, it doesn't burn. And you should have most of your skin covered. We don't allow shorts or anything, pants or leggings with holes in them, like today's, should I say, style is stylish to cut holes in jeans or other things by your knees and all that. When I was a student, it was to make them look like they were well worn, and some people would wash their jeans in a washing machine and put in some stones to help make them look real worn, even though they were new. Now you just buy new ones and break them in, come on. But anyways, also you need to wear closed toe shoes, and your pants should come down, or leggings to your ankles. And we enforce this. At COD, if we're working with chemicals in the lab, which we do, even water, all students must wear gloves, including the instructor too, which I do. And COD, if we're in a lab, we provide the gloves to you. Now, there are a couple of videos on safety, and you should watch this. And the ones in red, just to give you an understanding of working in the lab. Now, a couple important things, and take notes now. I'm not going to write it on the whiteboard, but you should take notes so you can answer the questions in the lab. First of all, goggles are probably the most important safety equipment you should have when you go into lab, and you should wear them in front of your eyes, not on your forehead, not around your neck, and not put on the bench top. And I'm very strict about that because of what I saw with my friend and his accident. And since then, I've been very strict, because the last thing I ever want to do when I'm working in a lab is have someone that I'm responsible for be blind because I didn't make them follow safety. Now, what do you do if you break something? In a lab, we're working with beakers, graduated cylinders, other items of glass, and students test tubes and they get broke. You should call the instructor. I clean up, and I know how to clean up broken glass so I don't get cut and you don't get cut. Next thing, what happens if you get something spilled on you? The procedure is put it under cold water for about 10 to 15 minutes. If you spill a chemical on yourself, that's the first thing. The second thing is tell the instructor, because I also know first aid at COD, I also will get help. And that's something you should know. Now, what happens if there's a fire? And that could happen. In my labs, it hasn't, but it could happen. You let the instructor know. I know how to use a fire extinguisher. You probably don't. If you do, and one of the videos I think shows it, when you use a fire extinguisher, here's your fire, always pointed at the base of the fire, not the top, the base. When I was in industry, because of the level I was at, the fact that I went to chemical plants, companies I worked for, I was given special training. Other people worked in plants were given the same training, how to use a fire extinguisher. And it was quite exciting. It got you over the fear of a fire. And what they do is they'd have a large container of gasoline about this high, about 4 by 6 feet, or 8 feet, like a sheet of plywood. That surface area filled with gasoline. They'd set it on fire, give you a red chemical fire extinguisher and put it out. And you'd practice. And then they had another one where about 6, 7 feet above the ground were pipes with holes in it. They'd pump gasoline coming out of it and set that on fire, and you'd have to put it out. And you got practice and you learn not to get upset and also how to use it. So if there's a fire, what do? You tell the instructor. Now, in a lab, we do not allow people to eat food or drink. We don't allow that. And if you have a water bottle, that's to be kept in your backpack, put away. Why? Because chemicals can get into your food and anything you're drinking and contaminate it. And if you ingest it, you can get real sick. So you never, ever bring and eat food or drink in a lab. Never. And I enforce that too. In fact, when I teach in a lab, if I'm lecturing and I'm thirsty, I'll take this water bottle and I'll walk outside in the hallway for a second or two, then I'll drink and I'll come back into class. And students can do that too. Now, an important thing is called the Msds, or safety data sheet. And the safety data sheet is every chemical manufactured and sold in the United States has what's called the material safety data sheet, or MSD, and chemicals have different labels on here. And you should look at this and look at the main video up here about safety placards. And a lot of times you'll see this on a truck. I should point out, anything we do in the lab, and I teach in the lab, will never be on an hourly exam or final. Anything we do on the lab will never be on an hourly exam or the final. I keep lab and lecture separate, but you do have to learn what I'm teaching now to answer questions in the lab. So you get your 10 points. I hope you want to do well. Now, every chemical has what's known as the Material Safety Data Sheet, MSDS. And they have certain symbols here, the NFPA. And you should learn these symbols. And there's a good video to watch this right here. Now, how do you find in the labs? We have the Msds, the material safety data sheets for any chemical you handle. And that's important because it gives in there what's the name, pictograms telling you what hazards, statements of the hazards, and precautionary statements. And what they don't have here is if you get it on you, how to deal with if you get it on your skin or inhale it. And if it happens in a lab and an instructor doesn't know how to do that, they can look up the Msds. Now, when we look at the pictogram over here for different colors, blue is health, red is fire hazard, yellow is reactivity, and white is special hazard. I didn't know it was a special hazard. But anyways, 1 is the highest hazard, 4 or 5 is lowest. And let's take a look at 1. Let me show you. Does everybody see? Let me go to. Does everybody see Google on your screen right now? Thank you. Let's think of a chemical. 2-butoxyethanol. And to find the Msds for that, afterward, I'll put this. And notice different companies I have, and Fisher is a well-respected company. I can click on that. And does everybody see safety data sheet? That's another name for it. And here it gives you the names of that. I typed in 2-butoxyethanol is another name. And then hazards. Notice flammable, not that bad. And skin corrosion. And is it flammable? And things certain. If you get it on you, what you should do. If you inhale it, call a poison center. Some of these, and I've written these for companies I worked at for molecules I've created. We have different things in case of a fire. How do you put it out? And different things. And here it gives you the composition and what's first aid. So this is quite useful. Now this is an older one because it doesn't have the hazards. Let's do one real hazardous. And this is a well-respected company. And here they have sodium. And notice they have pictograms for shipping and other things. I can't see the pictograms right now, but these are very important documents to have around. Now, for today's lab, does everybody see safety lab? I made a mistake. I hit the wrong button. That should be 11:05. You have your name, and then I have a number of questions. If you were paying attention, by the way, you can go back and play the video. I'll have it posted today or tomorrow morning. You answer these, and then you can find out. You'll upload it, and then I will grade it. So this is what you download, the safety lab, and then when you upload it, you just have to do the name and the questions on here. And that's today's lab. And with that, I'm done. Like I said, normally if we were in lab, if we're doing actual labs, now you go and do it after I give my introduction. Well, safety lab, I'm not going to show you the videos. You can watch those on your own. And with that, I'm done. Gang gesund. Before I say that, the safety lab is due next Tuesday. You upload it to the assignment area for lab 1. When you open it up, there's a place where you can upload a file, upload it as a single PDF. Remember, it's due next Tuesday. The lab is always due on the next lab period by the end of, say, since I'm teaching, I think I have it till 4 o'clock. You have to get it in. So this lab is due next Tuesday. The lab we do next Tuesday will be due Thursday. And my labs are not hard. I don't have you write 30 million pages for a lab report. But if you don't hand it in, you get 0 points. Or if you're late, you get 0 points. I don't know about you, but I wouldn't want to get 0 points. So get it in. And if you have questions, what do? Ask. Because remember my policy, there's no such thing as a dumb question that pertains to labs and also anything else you have a question for that I could help you out with this course, or maybe some other things too, but I haven't figured out the meaning of life yet, so don't ask me that. But with that, I'm done. I'll see you on Monday. We don't have any class tomorrow. Uh, if you suffer Dr. White withdrawal symptoms, you can go look at me on YouTube. And with that, thank you very much. And I'll say, gang gesund, be healthy. I'll see you on Monday. Bye now.